Hello everybody, in the name of God, my name is Mehdi Kordnavarsi and this is my sixth movie about the software architecture and design, chapter 4, a technique for architecture and design of the applications. We start about the topic designing for issue mitigation, how we design the application to minimize the risk and the errors in the runtime. By analyzing quality attributes and cross-cutting concerns in relation to your design requirements, you can focus on a specific area of concern. For example, the quality attribute security is obviously a vital factor in your design and applies at many levels and areas of the architecture. The relevant cross-cutting concerns for security provide guidance on a specific area where you should focus on your attention. You can use the individual cross-cutting categories to divide your application architecture for further analysis and to help you identify application vulnerabilities. This approach leads to design that optimizes security aspects. Questions you might consider when examining the cross-cutting concerns for security are: the first is auditing and logging. Who did what and when? Is the application operation normally? Auditing refers to how your application records security-related events. Logging refers to how your application publishes information about its operation. The second one is authentication. Who are you? Authentication is the process where one entity definitely establishes the identity of another entity, typically with credentials such as username and password. The third is authorization. What can you do? Authorization refers to how your application controls access to resources and operations. And the fourth is configuration management. What context does your application run under? Which databases does it connect to? How is application administered? How are these settings protected? So, configuration management refers to how your application handles these operations and issues. The next question is about cryptography or encryption. How are you handling secrets or confidentiality? How are you tamper proofing your data or liabilities or integrities? How are feeding random values that must be cryptographically strong? Cryptography refers to how your application enforces confidentiality and integrity. This part is about the encrypt the data when passing through the layers of the application. The next question is about exception management or error handling. When a method call in your application fails, what does your application do? How much information does it reveal? Does it return friendly error message to end user? Does it pass valuable exception information back to the calling code? Does it fail gracefully? Does it help administrators to perform root cause analysis of the fault? So, exception management refers to how you handle exceptions within your application. The next question is input and data validation. How do you know that the input your application receives is valid and safe? Does it constrain input through entry points and encode output through exit point? Can it trust data source such as database and file shares? Input validation refers to how your application filters, scrubs, or rejects input before additional processing. Next question is about sensitive data. How does your application handle sensitive data? Does it protect confidential user and application data? Sensitive data refers to how your application handles any data that must be protected, either in memory or over the network or in persistent source. The next question about section management. How does your application handle and protect user sections? A section refers to a set of related interactions between a user and your application. You can use these questions and answers to make key security design decisions for your application and document these are part of your architecture. For example, the next figure shows the security issues identified in a typical web application architecture. In this figure, the user connects via the browser and the authentication user happens in this part and send some queries. So these actions happen preventing parameter manipulation, protecting sensitive data, and preventing session hijacking and cookie reply attacks in this part. And after these filters, the data will send to the firewall layer, and after that, a web server here execute a web application, and some action happen in this part are providing secure configuration, handling exceptions or error handling, authorizing users again, and validating input. If all of these conditions happen, the result will send to the another server, application server, is the host of the many application programs, and appropriate application will run from this server. Again, authentication and authorizing upstream identities and auditing and logging activity and transactions happen in this part of the application. And the final query will pass through to the physical layer or database server. Sensitive data protect and encrypting or hashing sensitive data will happen on the storage to record or retrieve the data transfer between the other layers back to the browser. So in this part, we are ready to design the candidate solutions. After you define the key issues, you can create your initial baseline architecture and then start to fill in the details to produce a candidate architecture. You may need to modify your architecture a number of times through several iterations. Candidate architecture and by using multiple architectural spikes. This iterative and incremental approach allows you to get the big risk out of the way first. Iteratively render your architecture and use architectural tests to prove that each new baseline is an improvement over the last. Consider the following questions to help you test a new candidate architecture that results from an architectural spike. Does this architecture succeed without introducing any new risks? Does this architecture mitigate more known risks than the previous iterations? Does this architecture meet additional requirements? Does this architecture enable architecturally significant use cases? Does this architecture address quality attributes concerns? Does this architecture address additional cross-cutting concerns? Let's see about architectural spikes. Is a test implementation of a small part of the application's overall design or architecture. The purpose is to analyze a technical aspect of a specific piece of the solution in order to validate technical assumptions, choose between potential designs and implementation strategies, or sometimes to estimate implementation timescales. By focusing on key parts of the solution's overall design, architectural spike can be used to resolve important technical challenges and to reduce overall risk and uncertainty in the solution's design. Okay, let's see a short movie about why testing is important. 2 minutes together.
What is software testing? Software testing is a process to identify the correctness, completeness, and quality of developed computer software. It includes a set of activities conducted with the intent of finding errors in software so that it could be corrected before the product is released to the end users. In simple words, software testing is an activity to check that the software system is defect-free. Why is testing important? This is China Airlines Airbus A300 crashing due to a software bug on April 26, 1994, killing 264 innocent lives. Software bugs can potentially cause monetary and human loss. History is full of such examples. In 1985, Canada's Therac 25 radiation therapy machine malfunctioned due to a software bug and delivered lethal radiation doses to patients, leaving 3 people dead and critically injuring 3 others. In April of 1999, a software bug caused the failure of a $1.2 billion military satellite launch, the costliest accident in history. In May of 1996, a software bug caused the bank accounts of 823 customers of a major U.S. bank to be credited with $920 million. As you see, testing is important because software bugs can be expensive or even dangerous. As Paul Ehrlich puts it, to err is human, but to really foul things up, you need a computer.
Okay, thank you for watching this movie. And for the next movie, we are talking about what to do next to complete the techniques of the architecture and design. Thank you.